Okay, hello everybody, my name is Jack Diorio, and this is my final project for Modeling Complex Systems 1. So I called my final project the Ecology of Opinions, and my question was, how do related opinions spread throughout a population? So this had been explored before with the voter model, but I wanted to add an extra level of complexity to it, where opinions could be related to each other. And the way that we did this is a network or graph called the rule set, which is just kind of an edge list in the code and sits right here. So we can see that we have an opinion rule set, which defines how different opinions, which are just labeled with letters because it's, without loss of generality kind of deal. And then we have a population network, and right now loaded is the London Transport Network from Neschleuder. And then we can see that we also we track a bunch of counts and centrality and initialize a bunch of zeros so that we can collect some data from it. So moving on to the methods, I decided that the rule set graph was going to have weighted undirected edges, and the weights would be this phi coefficient. And essentially all it is a measure of correlation between two binary random variables, and the opinions are the binary random variables. You either have the opinion or you don't. So once we have this phi coefficient between all of the different nodes in the rule set graph, we can calculate a probability that you'll adopt an opinion that someone speaks to you about. So you can see here that this is the mathematical definition. Essentially all it is a weighted sum which is normalized and then passed through a sigmoid centered on 0.5 to achieve a probability. You can see here this is the weighted sum. This is my tilde s, and then I pass it through a sigmoid centered on 0.5. I have alpha set to 6, and the reason I set alpha to 6 was after a few parameter sweeps, I found anything less than 6. The sigmoid was too centered around 0.5. It wasn't using the full 0 to 1 range, and anything above alpha of 6, it was clipping it too hard. So at each time step, a random node is selected, and you can see that right here, and a random neighbor is selected, and they talk about a random opinion, an opinion that the speaker holds. Then here we calculate the spread probability using the math, and if they do adopt the opinion, we look back at the rule set graph and find a maximally positive cluster of nodes. And I do this with a very simple algorithm out the box right here in this positive cluster function. You can see that I'm only following positive edges, and I only use edges the node believes in. And what I wanted to achieve with this effect is that I'm finding kind of the most positively correlated subgraph of beliefs, aka like the most coherent subset. So if you believe in opinion A, B, and C, and I speak to you about D, right, and you adopt D, we go off the assumption that you now want to keep the opinion D, and you try to work the rest of your beliefs around that structure. So this is the main loop, and it runs however many times you'd like the simulation to run. Initializes opinion arrays, and the way I did this had nothing to do with positive correlation, so often nodes start with very conflicting opinion arrays. And then I've got the counts here, and the node swishes gets initialized, and then I loop over each time step. And a random node is picked, a random neighbor is picked, they speak about a random opinion, calculate spread probability. If it succeeds, we do the positive cluster, and we change everybody's opinion, and then we update the counts so that we can collect the data. Then we save all the counts into a larger array and average them. And below this line is just really malleable matplotlib code area that I kind of sandbox around with to produce a bunch of figures. And one of the best figures produced is this, which is the average opinion dynamics over 100 runs. This is really cool because in my paper here, you can see that what this is actually showing, and if you read the rest of it, it'll become more clear that this graph represents polarization within a population. When we structure the rule set graph of nodes in such a way that you get two polarized cliques of ideas or beliefs, turns out operating over the London Transport Network, people are less likely to pick the center ideas and more likely to pick ideas that are far on the edges of their cliques, the most extremist views. And that was a really cool piece of emergent behavior that I observed. I saw some other emergent behavior as well, but I don't think this presentation is supposed to be a dissection of the paper. It's supposed to be more of my code. And yeah, that's my code. I've got my matplotlib here. This is the main simulation loop. I run through it however many times to get averages, and then load the data up, and yeah, that is everything. Thank you.